Hey, the new episode's ready. I'll be there in 10 minutes. Alright, I got the new episode.
Great, let me see the thumb drive.
It's right.
Where is it?
It was here.
Uh-oh. Welcome to the Tech Junkies, episode number 6.
That's right, we got a pretty cool project for you today. And let me pitch you a scenario first. Say you've got your computer in your room at your house, and you've got a living room, a dining room, kitchen, you know, a different room in your house that you want to get streaming audio to, maybe just internet radio or possibly even music from your own collection. But you don't want to have to use, you know, your full-fledged computer out there, or drag around a laptop, or something less ideal like that.
What we've used in the past was the squeeze box. And this works great because it's just got an Ethernet connection. This one happens to be wireless as well. And it's just got a set of audio jacks in the back. And it's got a remote control, so you can take this anywhere you want. But the problem is it's meant to really be connected all the time. And so they're pretty expensive, and to have one of these in every room of your house really isn't ideal.
So, a website I came across the other day, mightyohm.com, had a pretty cool solution for this. This is an Asus off-the-shelf wireless router. This is, in particular, the WL-520gu. And coming in at around 30 bucks refurbished, and that's shipped price, this is not bad at all. You can basically use this as a full Linux machine once we hack this up a bit. And the reason you can do this is that it actually has a USB port, which is originally designed for print sharing on your network. But what we're going to do is just get one of these little USB sound cards, and this is one we just had lying around. This one's a little bit bigger than I'd like, but you can find ones that are literally slightly larger than the USB port that you're plugging it into. So we're going to load on some hacked firmware onto this, some software called OpenWRT, which is basically just a Linux distribution, a really tiny distro that you can fit onto the memory of one of these.
And I like this idea too because it's about the same size as that router. It's pretty small. So it'll fit anywhere, and for 30 bucks a piece, this is going to be a great solution.
And of course, since it's got the Wi-Fi already embedded into it, you don't even have to worry about running wires to it besides power. So let's get to it. Alright, so we've got the wireless router over here now. Just a few things we've got to do to get this set up with our computer. And for this demo, we're going to be using just a Mac Mini. You can do this with any operating system, PC, whatever you want. You're going to have to find a little bit different software. We're using a TFTP client, which is actually going to let us transfer the files to the router. But you can find those for any operating system, so it shouldn't be too much trouble. So first thing we're going to do, just take a straight Ethernet cable here. We're going to plug one end into the LAN 1 port of our router. And now we're just going to connect this into the Ethernet port of our computer. So now we've got a direct connection between the computer and the router, and now we just got to apply power. So we'll just grab our power now, plug that in, you should see the lights power up, and we should be good to go from our computer now. Okay, so the first thing we need to do is set up our networking on our computer. Obviously this is going to be a little different on whichever operating system you're using, but it's the same basic concept. So first off, I'm just going to disable my wireless to make sure this doesn't conflict with any of the stuff we're doing with the router. And now I'm going to go into my network preferences. And we want to set this up manually, or also known as a static. So for our IP address, we're going to make that 192.168.1.185. Subnet should be 255.255.255.0. And router is going to be 192.168.1.1. So I'm just going to go ahead and apply that. And now we should be all set for networking. Okay, so now that we've got our network settings all set up, now we just have to put our router into restore mode. This is pretty simple. Now we're going to pull out this power cable, and I'm going to use a pen here because it should be the easiest. And you're going to want to hold down the restore button, not the easy setup. The restore button is black and it's recessed in a bit more. So we're going to hold this in here, and while you're holding that button down, you want to plug in the power, just like that. And now you'll see on the front, we're going to wait until our power light is blinking once a second, just like that. And now you can release the restore button. So this just put our router into restore mode, and it's waiting for us to upload a new firmware image to it. Now we're going to use the firmware image that was provided on mightyohm.com, and this is already pre-built, already has our sound drivers, all that stuff rolled into it, compiled, ready to go. So we're going to go back to the computer now, and we're going to send our hacked firmware image of OpenWRT to this router. Okay, so the router is in restore mode and it's waiting for a firmware image. Now you can do this a few different ways. On a Mac, we're just going to be doing this with the TFTP client to send the file to it. But on Windows, I've heard some success of using the Asus Restore utility that actually comes on the disk with the router. I haven't tested this, but from what I've read online, it should work. And if you're using Linux, it should be fairly similar to what we're doing here. So I'm just going to open a terminal here. And you can see I've placed the image from mightyohm.com here on my desktop. So I want to change my directory into where this image is at. So I'm just going to change directory to desktop. Now all I have to do is start the TFTP client, type trace, timeout of 1, mode binary, connect to our router's IP, which is .1.1. And now we're just going to put this firmware image. So OpenWRT-BRCM-2.4-squash fs.trx. Now press enter, and it's currently sending the firmware image to the router. So we just give this a few minutes here. Not even that, shouldn't even take that long. And you can see it just finished sending the firmware image, and that only took 10 seconds. So now this is the point where you want to walk away, wait a whole 5 minutes. If you interrupt this while it's in the middle of this, you could brick your router. So I'd suggest just waiting 5 minutes, and we'll come back and finish it from there. So we've waited a whole 5 minutes, and we're just going to unplug the power here. Wait a few seconds here, and then we're going to plug this back in. And when this boots up, we're going to give it another 5 minutes just to be safe, let it configure itself, do all that stuff, and then we're going to try and log into it. So power this back up and let it sit for another 5 minutes. Okay, so the router's been power cycled and we waited 5 minutes for it to set itself up. So now we can go ahead and just quit this TFTP terminal we had open. That's fine. And now we're going to try and telnet into the Asus router. So I'm just going to type telnet 192.168.1.1, and what do you know? There's OpenWRT, and everything appears to be working well. Now if you read up here, it says you can disable telnet and enable SSH by setting a password. Now this will be a bit more secure, so I'm going to go ahead and do this now. I'm just going to enter TTJ for the password. And there we go. Telnet should be all set up now, should be disabled now, and SSH should be set up. So we can go ahead and exit this terminal window. Now if you're on Windows, a good SSH client is called PuTTY, and you can just do a search for that and you should find it pretty easily. But I'm just going to go ahead and SSH to the IP of the router, and now I have to specify that we're logging as root, so I do -L root. There we go, SSH appears to be working, enter TTJ, and now we're logged back in. Okay, so at this point we can begin to configure the wireless so that this router will actually connect to our existing wireless network and it can get internet connectivity to stream the music. So I'm going to use VI for this, and if you're not familiar with VI, I'll just give you a quick recap here of how to use it. So we'll do vi/etc/config/wireless. It's our wireless config file. Now to actually edit in VI, you have two different modes. You have a regular mode where you can send commands and whatnot, and then you have an edit mode. So I'm going to hit the I key to go into edit mode now. The first thing you want to change is the channel, and this is the channel of your existing wireless network. So if you don't already know this, you'll probably have to log into your own router, the one that's already existing, and look up the channel. But I know the one here is running on channel 11, so I'm just going to enter that. Now down here, we have to comment this line out to actually enable the wireless, so I just use a pound. And now down here, we want to change the wireless mode from AP to STA, and that's actually going to make this a wireless client that connects to our existing network rather than broadcasting its own network. And the network here is called BARCH, so SSID, obviously just your network name. And then you have the option to use encryption if you have encryption enabled on your existing wireless. If you don't, just leave it as is like this, but personally I'm using WPA2 pre-shared key, so I'm just going to do PSK2, and all of these modes are available on the OpenWRT site. And now I just have to do option key, and right now it's TTJ, TTJ, TTJ. So to save in VI, hit escape to exit edit mode, :W to write the file, and :Q to quit. So now our wireless should be all configured. Up next, we need to configure the actual networking. So we're going to do vi/etc/config/network. Go into edit mode, and there's not too many things to change in here. We want to go down to the IP address right here. Obviously, you're going to be running an existing wireless network, and your router is probably either going to be running on .1.1 or .0.1. So we want to make sure we don't conflict with that. So we're going to make this just pick an IP address that's not in use on your network. For instance, I'm going to use .10. All this other stuff should be fine. And then we also need to add our gateway. This is the IP of your existing router that's actually routing out to the internet. So this actually is 1.1. And now we just need to set up our DNS so it can actually resolve names. And for this, I'm just going to use Google's DNS server, easy to remember, 8.8.8.8. So now your networking should be all configured, and we should just be able to write this file, quit, and now we can cycle the networking setup, /etc/init.d/network, and we can just restart this, and this will reconfigure the whole network and all that stuff. So we can just hit enter on that, give it a few seconds, and now we should be able to log back into this with that IP address. And at this point, hopefully your Asus router is going to connect to your existing wireless network, and we should be able to unplug the Ethernet cable. So I'm just going to do that right now. And now I'm just going to enable my wireless and connect to the same wireless network that hopefully our Asus router just connected to. So I'm just going to open up a new terminal again here. We're going to try SSHing into that new IP address. So SSH 192.168.1.10, specify root, and look at that. Looks like it's successfully connected to the wireless network and set up its new IP address. So at this point, we're good to start configuring the package manager so we can actually get the packages we need to play the audio. So I'm going to do vi/etc/opkg.conf, and this is the configuration file for our package manager of where it's going to get its packages. Now, this is the default that downloads out of OpenWRT. We actually want to switch this to Mighty Ohm's repository, I guess, is what you call it, and grab his packages because he's already got everything we need to set up music streaming. So this is mightyohm.com/files/kamikaze-2.4/packages/mipsel. Okay. So go ahead and save that, quit, and now we can do a package manager update. Just like that. And there we go, connected to a server, updated, so it looks like we're all set there. And now we're just going to go ahead and install the USB audio packages that we need. So we're going to do opkg install kmod-usb-audio and kmod-usb-ohci. Press enter, and now it's going out to his site and it's pulling down all these packages, and then very soon here you're actually going to see it configure them right there. And it's actually a really quick process, which is nice. And as soon as this completes, we're just going to issue the reboot command, and at this point you're going to want to plug in your USB audio device. So we've already got it plugged in. All we have to do is reboot it, and hopefully the Asus router will detect that USB audio. So now we just have to wait about a minute or so and we should be able to reconnect. Okay, so we've waited about a minute. Let's try an SSH back into our Asus router. There we go, came back online. And now we just have to set up the actual software that's going to play the music from the remote server. So for this, we're going to be using some software called Music Player Damon and Music Player Client for actually controlling it. Now, Music Player Damon is actually really cool because it has a remote port that you can log into with a lot of different clients and control it. So there's even an iPhone application, I'm sure there's something on Android, and there's all sorts of desktop clients that you can use on your computer to control this. So it's really nice. You'll be able to control it from practically any device you already have, which is really nice. So I'm going to go ahead and do an OPKG install of Music Player Damon and client. Actually, before we do that, we should update our package manager, and now we should be able to install it. There we go. Okay, so that's downloading those packages, and then momentarily we'll see it being configured. It's taking a little bit longer than the USB audio stuff, but it's very nice being able to control this from just an iPhone or even an iPod Touch, because then you can just connect it to your wireless network and log into your streaming box and control it from anywhere in the house, which is really, really cool. So it's almost done configuring here now. There we go. So we're just going to go ahead and set up the actual files for Music Player Damon now. So I'm going to make directory mp.mpd, make directory music, make directory.mpd/playlists, and now we're going to edit the mpd.conf file. Go into edit mode, and there's just a small little change we need to make in here so it actually uses the proper device, and this is how we're actually going to set up our audio device. Right here you want to go to an example of an OSS output, and we're going to uncomment this block of lines right here. And now we just need to change the device to /dev/sound/DSP, and that should be it for that. So just save that file and exit. Now we should be able to start Music Player Damon. You'll see an error on the first runtime, not a big deal. We don't need to set that up. It's making its DB file. And now we can test if the server's up by running the client MPC. Now if it shows volume 100%, repeat off, random off, that means it's successfully connected and we've got Music Player Damon running. Now to add something to the playlist, do MPC add, and I'm just going to enter a stream from di.fm here. Let's go u12.di.fm. A good place to find internet radio station streams is Shoutcast. You can just search for that, and you can download the PLS files, which are pretty much designed to open in any player, and you can open those in a text editor of some sort, and you'll actually be able to find these URLs that are the actual music streaming servers. So we've got that added to the playlist now, and all we should have to do is type MPC play, and there we go. It's successfully connected to the stream, and it's now playing the music. Now something you might want to do to automatically start Music Player Damon when you start up the router, that way you don't have to log in through SSH every time to configure it, is I like to do a symbolic link ln-s etc.init.d/mpd /etc/rc.d/s93mpd. So this is actually going to take the startup script for Music Player Damon and put it into our startup directory. So every time you start the router, it's actually going to start Music Player Damon automatically. And one other small change I like to make is to vi this init.d/mpd and actually go into the script that starts Music Player Damon. And what I like to do down here is I'll just comment out these lines. We don't need to automatically play. We'll leave repeat in there just so if the stream drops out, it'll automatically try and jump back into that. But I like to do /user bin/mpc add, and now you can add in our actual stream URL so that every single time this router starts, it'll automatically populate the playlist with all of your favorite radio stations. So you can add as many lines in here as you want that just add different streams to your playlist. And then once you're done with that, you can actually, if you want, you can even put in to automatically play it by doing MPC play like that. Now I usually don't want it to immediately start playing music when my router boots up, so we can leave that commented out. But I just like to automatically have it add all my streams, and then I can log in with my iPhone app and just click play, and from there my playlist will pop up and I can select which stream I want it to start, which is really cool. So to save this, just write the file and quit. And now you should have a completely configured Asus router, which can now connect to internet radio streams and play it. You don't need a computer. All you need is a wireless network, some speakers, and the router, and you're good to go.
That wraps up the Tech Junkies episode number 6, where we've turned our Asus router into a music streaming player.
Yeah, that's right, and it's pretty cool to think that for 30 or 40 bucks, you've got a whole Linux machine here with audio output. I mean, really the possibilities are endless at this point. We're just getting you guys started.
There's another way to work with this device. There's a serial port connection inside where you have to actually connect wires to the circuit board. And then you're able to hook up like an LCD screen or do other things through that serial port as well, which is pretty cool.
If you go to Mighty Ohm's site, where we got this idea from, you can see his whole enclosure, which is really cool. He's got speakers inside of it, he's got LCD screen, controls on the front, everything like that. We're hoping to show you how to do some of that stuff in the future, but we figured for now we'd show you how to do the software hack. That way when we get a little bit more hardcore with taking this thing apart and wiring into the serial port, it'll be easier for you to understand what exactly we're doing.
So until then, thanks for watching the Tech Junkies. I'm Ben.
And I'm Eric.
Thanks for watching the Tech Junkies. I'm Ben.
And I'm Eric.
See you later. Or you can cut out see you later. I don't know if there's something in there. Welcome to the new Tech Junkies episode. Welcome to the old Tech Junkies episode. Welcome to the semi non-polished at all episode. Very rough cut. Take 1.